this lecture we are going to study the transformation of two intersecting lines. What we are going to study here? The transformation of two intersecting lines. So before that, start with the actual transformation of two intersecting lines. We are going to see the equation of line. How to find out the equation of line, because that points we require while we are using the doing the transformation of intersecting line. So before start with that actual point, we will see how to find equation of a line. There are so many different ways through which we can find out the equation of a line. One of these is y minus y1 is equal to m x minus x1. So what is here m, where m is slope of line, where m is slope of line. So using the slope of the line, we can identify or find out the equation of a line. And we also know that m is equal to y2 minus y1 upon x2 minus x1. If there are two lines, then slope of the line is if it line has 2 points from here to here, this is the first point x1 y1 and this is another point x2 y2, then how we identify the slope of the line? M is equal to y2 minus y1 divided by x2 minus x1, and using this slope we can find out the equation of a line. So some examples we will see, simple example we will see first. A, B, suppose these are the 2 points. This is the point A and this is point B on the line. End points of a line is equal to 0, 1, 2, 3. Okay. So for this we are going to identify or find out the equation of the line. So to find the equation of the line, what we need to find out? First we need to find out m, slope of the line, which is y2 minus y1 upon x2 minus x1, which is equal to, so here it is x1 and this is y1, this is x2 and this is y2. So y2 minus y1 means 3 minus 1 divided by 2 minus 0. It is 2 divided by 2, 1. What is the slope of this line given? The slope of this line given is equal to 1. Now using this slope, put it in the equation. The equation of line AB is equal to, the equation of line AB is equal to y minus y1. What is y1? 1. Y minus y1 is equal to slope x minus x1. What is x1? 0. It is y minus 1 is equal to x, or we can write it in simple way. Y is equal to x plus 1. Y is equal to x plus 1. What is this plus 1? It is y intercept. Y is equal to x plus 1, where 1 is y intercept. Where 1 is y intercept. Is it clear? Now see, what is this y intercept and x intercept? It is, I think some of or most of you know what is x intercept and y intercept, but again I am explaining it in simple way. Suppose this is x and this is y axis. Okay, and suppose there is a line like this. Okay, suppose there is a line like this. So in this case, what is x intercept and what is y intercept? The x intercept is the point where a line crosses the x axis. where the line crosses the x-axis. So in this case, what is x-intercept? It is 3.5. What is x-intercept? It is 3.5. And what is y-intercept? It is 2. Okay, so that is x-intercept and y-intercept. So in this example, for this line AB with the points 0, 1 and 2, 3, the equation of the line with the help of slope is equal to y is equal to x plus 1, where 1 is y-intercept. So using this simple method, we can identify or find out the equation of a line. But this is the single way to identify the equation of a line? No, this is not the single way to identify the equation of a line. There are so many ways in which we can identify or find out the equation of a line. Now see here some of the forms for the equation of line or methods. Through which we can identify the equation of line. First method is slope-intercept. Slope-intercept. That already we have seen y is equal to mx plus b, where b is y-intercept. So that is the first method, or that is the first form of the equation of the line. Then point-slope method. Point-slope method, y is minus y1 is equal to mx minus x1, where x1 and y1 are the points on the line, or starting points on the line. x1 and y1 are the starting points on the line. Third way, standard form. Okay, this ax plus by is equal to c, where c is the constant value. Then using both intercept y and x, two intercepts, how we identify the equation of a line? X divided by a plus y divided by b is equal to 1, where a and b are x and y intercept, where a and b are x and y intercepts. Using this also, we can identify or find out the equation of line. Suppose the next is vertical. Vertical line. Vertical line means what? See, like this. Suppose this is x, this is y. Okay, I draw a line from here to here. So what we observe here, suppose this is the starting point, this is the end point. If a line is vertical, then the value of x is always same. All points on the x coordinate have the same value a. You can observe here, all points in the x coordinate have the same value. Okay, so x is equal to a, indicate that the line is vertical line. 6, horizontal. Horizontal means, suppose I draw here. Okay, suppose I draw here line from here to here. This is the first point A and this is the end point B. This line is horizontal, means what? Here all the y coordinate values are same. All points have the same y coordinate value. Y is equal to B. Then we can say that the line is horizontal line. Here suppose the values are 1, 2, 1, 4, 2. Here these values are 1, 1 and here 1, 3. Means for vertical line x values are same while for horizontal line y values are same. Using this equation, different line equation, we are going to see the next topic related to the transformation of intersecting lines. Transformation of intersecting lines means here we are going to consider there are two lines which are intersect with each other, and using general 2 into 2 transformation matrix, if we transform these two intersecting lines, then it generates another set of intersecting lines, and means we can consider it as a proof. That's to show if we transform two intersecting lines, then it generates another set of intersecting lines. See, for example, here you can see this one original line AB, this original line AB, okay, and this is another line EF. These are two intersecting lines. These two intersecting lines, if we transform, then it generates another set of intersecting lines A star, B star and E star, F star. So how it actually show that this transformation of intersection lines, we'll see with equations, or again here we require the slope of line. Okay, again we require here the slope of line. So I write it here. Let us consider a set of a pair of, instead of set I write here pair. Pair of intersecting lines. Two lines we consider here. We represent these two lines with the help of slopes like this. Y is equal to m1x plus b1 and y is equal to m2x plus b2. What is this? This is the equation for the equation of first line, and this is equation of second line. Equation of second line. Y is equal to m1x plus b1 and y is equal to m2x plus b2, where m1 and m2 are the slopes of these two lines and b1 and b2 are the y-intercept. So that one we can write it in like this. b1 is equal to minus m1x and b2 is equal to minus m2x. b2 is equal to minus m2x plus y plus y. Okay. Now this equation we write it in matrix form. This equation we will write it in matrix form. We write it in matrix form as like this: x, y multiply with this one. How we write it is minus m1 minus m2 1 1 is equal to b1 b2 is equal to b1 b2. If you multiply this, what happens? This one with this one minus m1x plus y, and it gives minus m2x plus y. So the same two equation we write it in matrix form. We give or assign it the capital X symbol. Okay, assign it the capital X symbol for xy. Capital M indicating the slope matrix is equal to capital B is the intercept values B1 and B2. It give the as the equation number 1. Now see, if solution to this pair of equation exists, okay, if a solution to this pair of equation exists, okay, then the lines are intersect. Then the lines are intersect with each other. We have to prove that these lines are intersect. Otherwise, these lines are parallel. If not, if solution is not there for this pair of equations, then they are parallel. Then they are parallel. So how to find out this equation? To find out the equation, we need to obtain the matrix inversion. A solution can be obtained by matrix inversion. A solution can be obtained by matrix inversion. Means how we identify the intersect point xi, which is we write xi yi. Okay, xi yi, what is this? The intersection point. Means suppose this line intersect with this line. This point we call xi yi. What is it? Xi yi. The intersection point, it is equal to B into M inverse. B into M inverse. We call it as equation number 2. Means here to obtain the solution we require inverse. Okay. First we will see how to find out the inverse. How to calculate the matrix inverse. The simple way to calculate the matrix inverse is the adjoint method. So for that we are going to consider one example. Suppose A is equal to 1, 2, 3, 4. We write it in the form of A, B, C, D. Now to identify or find out the matrix inverse, first we need to find out the determinant of matrix A. What is the equation to find out the determinant of matrix A? AD minus BC. AD minus BC. So put these values A and D. 4 minus 6, correct? 1 multiply with 4, 2 multiply with 3, 4 minus 6 means minus 2. What is the determinant of this A? It is equal to minus 2. Next, here determinant should not be equal to 0, other than 0. Okay? Determinant should be other than 0 or not equal to 0. Why? If it is equal to 0, we cannot divide by 0. Correct? We cannot divide by 0. It is not possible, and that's why the determinant of the matrix should be other than 0. Then only possible to identify the matrix inverse. Next, we need to identify the adjoint of A. What is the simple method here? Now see here, it is given 1, 2, 3, 4. So identify the adjoint. First we need to make interchanging these 2 points A and D. We need to interchange A and D and make minus these 2 values. B and C we need to make minus. So after this, what are the values? 4 minus 2 minus 3, 1. Correct? How to identify the adjoint of a matrix? Adjoint of A is equal to, first we need to interchange these 2 diagonal points A and D and make minus B minus C. So after this, the adjoint of this matrix A is this one. Now A inverse is equal to 1 upon determinant of A multiplied with adjoint of A. Sorry. 1 divided by minus 2 multiply with 4, 3 minus 2, 1. So if we make the multiplication of this, it gives the result 1 divided by minus 2 multiply with 4. It is value minus 2, 3 by 2 plus 1 minus 1 by 2. That is the inverse of this matrix A. That is the inverse of this matrix A. Is it clear? Now, in our case, M is given there and we have to find out what M is given, minus M1, minus M2, 1, 1. We need to find out the M inverse. We need to find out the value of M inverse in our case. First, we need to find out the determinant of A. Sorry, determinant of M. AD minus BC. So AD means minus M1, minus M2 means plus M2. Or you can write it is simplicity M2 minus M1. So that is determinant of M. Now adjoint of M. Then interchange the diagonal points 1 minus 1 M1 and change its M2 and minus M1. Okay. First interchange the diagonal points, that is 1 comes here and 1 comes here and the minus M1 goes here. So that is adjoint. Now M inverse is equal to 1 divided by determinant multiply with adjoint of M. Which is equal to 1 divided by, what is determinant? M2 minus M1. Multiply with this adjoint 1 M2 minus 1 M1. There. After calculation, the inverse of the matrix M is one divided by M2 minus M1, M2 divided by M2 minus M1, then minus 1 divided by M2 minus M1, and minus M1 divided by M2 minus M1. So that is the inverse. That is the inverse. So that we require here in this equation, correct? How we identify the intersection points xi yi is equal to B into M inverse. Okay. B, we know that B is M1, B1, B2. But we need to calculate the inverse. We know M and we know B. But we need the M inverse, and we have calculated it here using this method, adjoint of the inverse. Sorry, adjoint of the matrix and determinant of the matrix. So using this, we will get this one, that is inverse of the matrix M. Now we put this value in that equation. We'll put that values in that equation. Hence, the intersection of the two lines is I write here xi is equal to xi, yi is equal to b into m inverse, correct? B into m inverse. What is b? B is b1, b2, and m inverse we have calculated 1 divided by m2 minus m1, m2 divided by m2 minus m1, minus 1 divided by m2 minus m1, minus m1 divided by m2 minus m1. Now try to simplify it. We will get, calculate it now. Multiply this b1 with 1 divided by m2 minus m1 plus this 1. So we will get the result b1 minus b2 divided by m2 minus m1. And second point, what we are calculating here? The intersection point xi, yi for the two lines. b1 m2 minus b2 m1 divided by m2 minus m1. Means using the y-intercept and using the slope of two lines, we can identify the intersection of two lines. We can identify the intersection of two lines using the y-intercept and the slope. So what is this? This is intersection of original line. This is intersection of original line xi and yi. This is the intersection of original line. Now calculate, we consider these two lines are transformed. Now we calculate the intersect of transformed lines. We consider that the lines are transformed and we are going to calculate the intersection of transformed line. If these two lines x1 y1 with point y x2 y2 AB, or we call AB and EF. If these two lines are transformed using the general 2 into 2 transformation matrix, we consider transformation of these two lines. Using general 2 into 2 transformation matrix A, B, C, D. Using a general 2 into 2 transformation matrix A, B, C, D. Then the equations of transformed lines are, then equations of transformed lines are y star is equal to m1 star x plus b1. Now everywhere we use the asterisk indicating that this is the equation of transformed line. Okay. This one we will give equation number 4. This is our equation number 3. Okay. Using the equation of the slope in the previous lecture when we studied the parallel lines, we already calculate the equation of the slope. So using equation of slope, mi star means the slope of any line. Now there are two lines, m1 and m2. So I write here general equation b plus d mi. It is the slope. Mi star means slope after transforming a plus c mi, where I is the number of lines, 1, 2, whatever the number of lines are there. So this part we have studied in the previous lecture. First, here you can see this equation. In parallel lines, we have find out the equation of or the slope of transformed line. It is m star, that is slope of the transformed line is b plus dm divided by a plus cm. So that one we are using here. The slope of transformed line is, so I write it here for both lines separately. For the first line, slope is divided by b plus dm1 divided by c a plus cm1, and m2 star is equal to b plus dm2 divided by a plus cm2. Together we consider equation number 6. The intersection of transform line is obtained by using this in the same manner. In the previous we have seen how the intersection of original line, in the same way we are going to find out the intersection of transform line. Already we know here the slope, correct, of transform lines m1 star and m2 star. Already we know the equation of the transformed lines. So using all these, the intersection of transformed line is, we need to here use the asterisk to indicating that it is the intersection of transform line. Previously we have seen the intersection of, here it is the intersection of untransformed or original line. Now here we are going to see the intersection of transformed line. Using the same b multiply with, again using the inverse method. Equation already we have identified or find out 1 divided by only, instead of using m1 m2 we use it with the asterisk or the star indicating that this is the inverse of transformed or slope of transformed line. After multiplying this, we will get the equation as we already identified in the previous original lines. Now we are going to put the values here, these values, correct? M1 star is equal to B plus D of M1 and divided by A plus C M1 and M2 star. So these values we are going to put here in this equation. Simply after calculations using the equation number 5 and 6, I am not going to write here the entire calculations. The intersection of transform line is equal to A of B1 minus B2 plus C of B1 M2 minus B2 M1 divided by M2 minus M1. See, after multiplying this one or putting all the values here, B1 star, B2 star, then M1 star, M2 star, after putting all these values, we will get this equation. B of B1 minus B2 plus D of B1 M2 minus B2 M1 divided by M2 minus M1. That is equation number 7. Okay. So these are the, what are these? Intersection of, what is this result? This is intersection of transformed line, not original, transformed line. This is intersection of transformed line. Now see, the origin line intersection already we have calculated. Correct? So this is equation number 4. This is the intersection of original line. Now this intersection we transformed. Okay, using the T matrix A, B, C, D, and we are going to see what value we will get. Have you understood? See, here we get the intersection of transform line directly. And previously we calculated here the intersection of original line. But this intersection we need to transform now using the transformation matrix A, B, C, D. So now transform intersection of original line using the transformation matrix A, B, C, D. So the intersection of original line is xi, yi. Multiply it with the transformation matrix A, B, C, D. So xi, yi. What is it? It is here B1 minus B2. Correct? What is xi, yi? B1 minus B2 divided by M2 minus M1. So that value I will write it here. Okay. B1 M2 minus B2 M1 divided by m2 minus m1 multiply with a, b, c, d. We will get here the simple equation a b1 minus b2 after multiplying these two matrices plus the first term we will get, that is x I star, and the second term and I write this equation number 8. What is this? This is the transformation of intersection point of original line. And observe this equation number 7 here. What is this equation? This is the intersection of transform line, and these 8 both are same. Means what it indicates that from equation number 7 and 8, it shows that they are identical. From equation 7 and 8, both are identical. Means when we transform the two intersecting lines, it generates the again another set of intersection line or another pair of intersection line. When we transform a pair of intersecting line, it generates another set of or another pair of intersection line. So the example for this intersection of transform lines, we consider two lines here, AB and EF. A with starting point -1 -1 and it B with 3 5 by 3. Similarly E and F. So to show that the lines generating which are also intersecting to each other, we first find out the equation of line AB. The equation of line AB. Using simple method, y minus y1 is equal to m into x minus x1. Means first we need to find out the m, that is slope. So slope is equal to y2 minus y1 divided by x2 minus x1. So what is y2 here? For line AB, 5 by 3 minus 1 means it becomes plus 1 divided by 3 minus 1 means it becomes 3 plus 1. It is 8 by 3 divided by 4, which is 8 by 3 multiply with 1 by 4. So the answer is 2 by 3. What is the slope here? The slope of this is 2 by 3, the first line. Okay. Okay. So that is m1 means the slope of the first line AB. So we write the equation of this one, y minus y1. What is y1? Minus 1. So plus minus minus it becomes plus. Slope m 2 by 3 x minus x1. x1 is again minus 1. So minus minus becomes plus. The equation is y plus 1 is equal to 2 by 3x plus 2 by 3. In short, or we try to simplify it, it is minus 2 by 3x plus y is equal to minus 1 by 3 is equal to minus 1 by 3. So that is the equation of line AB. Now, the next we calculate the equation of EF. The equation of EF is, again we use the same method, y minus y1 m into x minus x1. For that we need to calculate the slope. I call it m1 and it is the m2. Second line, y2 minus y1 divided by x2 minus x1. So EF line, it is 2 y2 minus y1. It is minus 2. Okay. Minus 2 minus 3 by 2 divided by 3 minus minus plus 1 by 2. So after calculation, it is minus 1. That is the slope of second line. So put this value of m here, y minus y1. y1 is 3 by 2 is equal to minus 1 slope x minus x1, that is minus minus 1 by 2. After calculation and or simplification, it is x plus y is equal to 1. That is the equation of line EF. First we need to find out the equation for both the line. Now we represent this pair of lines in matrix notation. Okay, we represent it in matrix notation x, y, okay, and minus m1 minus m2, that is minus 2 by 3, 1, 1, 1 is equal to intercept b1, b2. So b1 in the first line it is minus 1 by 3 and b2 is 1 for the second line. Okay, b1, b2 means this y intercept which is minus 1 by 3 and 1. That is b1, b2. That is b1, b2. Now xi yi is equal to b into m inverse, correct? Xi yi is equal to b into m inverse means we need to calculate the matrix inverse. So here calculate matrix inverse, that is m minus, means for this matrix we need to calculate the inverse. Now the equation we know, for that it is already we have seen how to find out the inverse and already we have calculated m2 minus m1, m2 divided by m2 minus m1, then minus 1 divided by m2 minus m1 and minus m1 divided by m2 minus m1. Okay, so put these values of m1 and m2 here. What is m1? Minus 2 by 3 and what is m2? Minus 1, correct? Here m1 is equal to 2 by 3 and m2 is equal to minus 1. That is being calculated here. m2 is minus 1 and m1 is 2 by 3. So we put these values in this equation and find out the matrix inverse. So it is 1 divided by m2 is minus 1 divided by minus 1 divided by and minus m1 means 1 by 2 by 3 minus 2 by 3. Now try to simplify this equation. We will get the result 1 divided by minus 5 by 3. After simplification or the calculation, minus 1 divided by minus 5 by 3, minus 1 divided by minus 5 by 3, and minus 2 by 3 divided by minus 5 by 3. Again we simplify it, and the final m inverse. What we are calculating? M inverse to find out the intersection of original line. Minus 3 by 5 plus 3 by 5 plus 3 by 5, and it is 2 by 5. That is our M inverse. Okay. What is it? M inverse. For which purpose is required? To calculate the intersection of original lines. So using matrix inverse, calculate intersection of lines AB and EF. What is the formula? Xi is equal to the intersection point xi yi is equal to B multiplied with M inverse. Means what? B1, B2 multiply with M inverse. Now put these values here in the equation. Previously we have calculated. This is B1 is minus 1 by 3. B2 is plus 1. Multiply with M inverse that we have calculated. Minus 3 by 5, 3 by 5, 3 by 5 and 2 by 5. After multiplication, the intersection points xi yi is equal to, after multiplying these two matrices, xi yi is equal to 4 by 5 and 1 by 5. Okay. What is this? This is intersection of original line. Now, consider the transformation of these lines. These original lines, we consider that these are transformed. Or before that, we transform this intersecting point or intersection point after transformation of intersection point. Okay, with the help of matrix, general transformation matrix T. So xi star yi star is equal to the intersection point xi yi multiply with the T. What is xi yi? It is 4 by 5 and 1 by 5. And the transformation matrix we consider 1, 2, 1, minus 3. This is the transformation matrix which we are going to use for intersection. What is this 1, 1? The after transformation of this intersecting point, we will get the new point, that is 1, 1. Now the original line we are going to transform and find its intersection point and see whether both are same. Now consider the transformation of AB and EF. And we use the same transformation matrix. T is equal to 1, 2, 1 minus 3. Okay. So first line we transform A, B multiply with T. What is our original line AB? It is minus 1 minus 1, 3, 5 by 3 multiply with 1, 1, 2 minus 3. And we will get the new line minus 2, 1, 14 by 3, 1. That is our transform line A star and B star. Same, the second line EF, transform it with this transformation matrix. So the EF points are minus 1 by 2, 3 by 2, 3 minus 2, 1, 2, 1 minus 3. So we will get the points 1 minus 11 by 2, 1, 12. That is E star and F star. Okay. Now see here in this way. You can observe here, this is the original line. Okay. Sorry. This is the original line A and B. So it is intersecting here. If we transform this intersection point, okay, this is the intersection point. If we transform this intersection point, it is equal to the same. It goes here after transform this intersecting point. This is the new line AB star and EF star. And what is its intersection point? Its intersection point is here. Now, if we transform this intersection point with the same matrix T, then we will get this point. We will get these intersecting points. Okay, what is it? 1, 1. Now see it here. So in this case, after again we need to use the same. What we need to use here? What here we need to use the same thing, that need to find out the M inverse and all these things, whatever we have seen. After completion or using all these things, the intersection point of these new transformed lines, intersection point of these new transformed lines A star, B star and E star, F star is 1, 1. Okay. What is the transformation of our intersecting point? Xi, yi, it is 1, 1. And what is the intersection point of transform line? It is 1, 1. Both are same. So it indicates that when we transform any intersecting lines, it generates another set of intersection lines or another pair of intersecting lines.